Good morning, everyone. Today we will discuss irrational numbers. You already know about rational numbers. Irrational numbers which cannot be written in the form of p by q, where p and q are integers and q is not equals to 0. For example, root 2, root 3, root 15, etc. Now, how to prove that root 2 is irrational? We'll prove by using method of contradiction. Means we'll assume that root 2 is rational. So we'll write, let us assume to the contrary that root 2 is rational. Now we have assumed, since we have assumed that root 2 is rational, it means root 2 can be expressed in the form of p by q, where p and q are co-prime and q is not equals to 0. Now co-prime means no common factor other than 1. Here p and q are co-prime means there is no common factor other than 1. Now transpose this q here to LHS and squaring both sides. So we'll get one equation, 2q square is equals to p square. Now after this, when you transpose this 2, you'll get p square by 2. P square by 2 means 2 divides p square. And if 2 divides p square, 2 also divide p. It means 2 is a factor of p. For example, if 2 is a factor of 8, then this 8 can be written as 2 multiplied by 4. Similarly, if 2 is a factor of 6, then this 6 can be written as 2 multiplied by some number. This is 3. So in general, we can write p is equals to 2 multiplied by c. Means 2 is a factor of p, it means p is equals to 2c for some integer c. Now we will substitute this value in equation number 1. So after substituting the value, we will get 2q square is equals to 2c the whole square, which is equals to this, and finally we will get q square by 2 is equals to c square. Okay, now again like this, here we can write 2 is a factor of q. 2 divides q square, it means 2 divides q, or 2 is a factor of q. 2 is a factor of q. Now from this 2 expression, 2 is a factor of p and 2 is a factor of q, we can say that 2 is a factor of both p and q. Now see, in the beginning we have taken that p and q are co-prime. Co-prime means there is no common factor other than 1. But here 2 is a factor of both p and q. So which is a contradiction to the fact that q and p both are co-prime. Okay. So we are getting something wrong. It means we have assumed something wrong. Means our assumption is wrong. And we have assumed that root 2 is rational. So our assumption is wrong. It means root 2 is not rational. It is irrational.